Okay, so we're going to talk about standard position of angles. And so we've got a really crude graph here. There's an x-axis and the y-axis, so we can just mark that really quick. When you're in standard position, there's two things that have to happen. Your vertex is at the origin, and your initial side is on the positive x-axis. So what? And I'm going to use some colors for this. I'm going to see if purple will show up. So if you're in standard position, your vertex is here. And that marker doesn't work. I'll just use my pencil. So your angle is going to have its vertex right there at the origin, and one side is always on the x-axis on the positive side. So this is what they call the initial side of your angle. So this part is always in the same place. So think about this as sort of a starting point, and then if I were to rotate it, then hey, I stopped right here. It's like I went from here to here. This is called the terminal side. But if you're going to have standard position, your vertex is at 0, 0, and your initial side has to be right there on the x-axis. So we're going to draw all of our angles that way on a graph and just talk about a lot of stuff, a lot of vocabulary, and just how to draw them with a protractor. Okay, so initial side, terminal side, that's your vertex at 0, 0. So then if we're talking about positive angles, because your initial side is always here, this is our starting point, this is going to be 0 degrees. If I turn this far, that's a right angle, and I have positive 90 degrees. And then if I turn another 90 degrees, I get 180 degrees. Another 90 degrees is 270. And then if I make a full circle, you've gone 360. You can keep going. We're thinking about angles in a different way. We're going to think about them as rotation. So you could keep going past 360 if you wanted to. It can keep going around and around and around, which we'll look at. All right, so we're going to start with some simple angles. So on this first one, it says they're going to draw a 50-degree angle. So my initial side is always going to be right here. This is the first side of my angle. So I have to draw that side first. You have an arrow on it because it goes forever. And then you'll take your protractor. And this is a really tiny graph, I'm realizing. So let me zoom out a little bit. So I have my protractor set right here. Here's my 0. And so I have to count up 10, 20, 30, 40, 50. And I'll make a mark up there, even though that's a little ways outside of my box. And then connect it down here. I don't have to draw it that far. I can just kind of get that line. And so this is 50 degrees, and one of the requirements when we are graphing angles is that you are now going to put this little arc this way, showing that we started at 0, we ended there, and you have to label it with 50 degrees. So this stuff right here is required. So instead of just drawing a random angle, we're putting it in a specific place. And the reason that we're doing this with the 50 is we can see it's not going all the way around and coming back there. It's just going that far. That's how far it's going in its rotation. So we're thinking of this as rotation. All right? So far we rotated 50 degrees. On the next one, it says draw a 140-degree angle. So we always start with this origin right here being where your hole in your protractor goes. And then if I want to always use the numbers that start from 0 over here. So I'm using the bottom numbers for this protractor. So I'm going 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So it's going to be out here a ways.
Next one more, it says 140.
Oh, does it say 140? Then I didn't go far enough. Thank you. Good job. So 140 would be over here. I didn't go far enough. And so then it goes here. So my initial side I need to draw down here. This is my terminal side, and then we're going to draw this little arc with an arrow showing that I went from here to here and that that is 140 degrees. Okay. Was I on the screen? There we go. So that's 140 degrees. So let's go down to 230. Now, 230 is bigger than this protractor has. It only goes from 0 to 180. So we're going to have to do a little bit of math first. So we're going to start with my initial side here. If I go from here to here, that's 180. So I need to figure out how much further I need to go. So I can take 230 minus 180, and we get 50 more degrees. So I need to go 50 more starting from here. So I'm going to flip my protractor upside down, and I'm going to go 50 more degrees, which is right here. I counted from 0 this way, and it's a little ways over there. And I'm going to show that this arc went a little further. So this part was 80, that part was 50. It adds up. I'll get rid of that. Now the whole thing is 230. Okay, so even bigger angle on the next one. Draw a 320 degree angle. So we always start from here at 0. So I know if I go from here to here, that's 180. If I keep going to here, then it's 270. So I have to keep going even further than that. So 320 minus 270, again, is going to be 50 degrees. So I have to go 50 degrees from here over. So you can take your protractor like this and find 50 degrees. If I'm on the screen, I am. And so to there. And so we just added another 50, and then that means that the whole thing is going to be 320. So I'm just going to get rid of these extra things from thinking and show that it goes all the way from here around to here, and that's 320 degrees. So we're turning. We're thinking of this as a rotation. It's turning. Okay, so now we're going to draw a 410 degree angle. So what's interesting about that, if I start from here and go all the way around, that's 360. So I need to go even further. So 410 minus 360 is 50. For some reason I used a lot of 50 degree angles. I apologize for that. So the actual measuring for this one is going to be just like it was for this one. We're going to have to go 50 degrees past the 0 mark again. So mark 50. You want to make this as accurate as you can. So here's my terminal side. And we do a spiral. So I don't know if you noticed how I was doing that. When I went around, I didn't meet up in the same place. That's so I can kind of spiral out. And then this whole thing, I had 360 and the 50, so the whole thing is 410. So you can keep going around and around and around and around and around as many times as you want. And that's how angles get played into rotation things. In physics, you can have a lot of rotation problems, and you have to understand that the angles can keep going. All right, so a vocabulary term, coterminal angles. So they have the same terminal side. So our example here, this is the 50 degrees, and then here's the 410. It started in the same place, it stopped in the same place, but this one went around a whole turn before it stopped. Does that make sense? Mm-hmm. So you can have an infinite number of coterminal angles because you can keep going around and around and around. So I'll show you how to get those. Doing okay, everybody? This is getting stuff written down. It's good because I wrote down quite a bit there. But you can see that it ended in the same place. It's just this one stopped really quick. This one went all the way around and stopped. So co means with, and then terminal, that's where it stopped. It terminated in the same place. So over here it says find 3 coterminal angles for 23. I'm actually going to break this up and do 3 positive, and I'm going to do 3 negative, because you could do either. And what you do for these is you're going to add.
What's the difference between a positive and a negative?
If we're adding or subtracting. So we'll talk about, that's a good question. We'll do the positive now, then talk about negative angles, and then come back.
Okay.
So if I want to find 3 positive coterminal angles for 23, I'm going to take 23 and add 360 because that adds a full turn. It is 383. So 383 degrees. And then I can take that 383 and add a 360 and we get 743. So what we're doing is add 360, add 360. You can take 743 and add 360. They just keep getting bigger. We get 1103. And so you can keep going and adding. So I'll come back and talk about the negative in a minute after we talk about negative angles. That's a good point. I did that really quickly, so I'll let everybody get it written down. But basically you just add 360s because adding a 360 just adds another full turn, and then you can stop in the same place. So this is really easy to do with the calculator. You just keep hitting enter, 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 and it'll keep adding the same thing. Okay, so 743, and then the next one was 1103. All right, so before we do the other, I'm going to look. This spiral's kind of the wrong direction, but I had to draw this on the computer. So we're going to figure out what this angle is based on its rotations and where it ended. So we will need the protractor for the last step. So I see, first of all, it goes around 1 full turn right there. So that's 360. And then it does another full turn, which is 360. It does a half turn, which is 180. So I really need to figure out what this angle is to add it on to see where it lands. So I'm actually going to extend this out, because that's why you have arrows on angles, is so you can make them go as far as you want. And then I might extend this side a little bit too, because that makes it easier. And then line this up. And I'm getting about, I got like 73. What are you guys coming up with? Is it closer to 70?
I
think it's supposed to be 70. I didn't draw this very good. Let me try that again.
I got 70.
I got in between 72 and 73.
Okay.
Yeah.
So we're not got super accurate tools here. Oh, that time I got 75. We're gonna say that it's like that little angle is like 72.
Okay.
And then we'll add them all up. So then it ends up being like 972 degrees.
Yeah.
And I'm off the screen. Okay. So this is a full turn, this is a full turn. So these are full turns or full rotations. This is a half turn, and this is just what was left over. And I measured only that last piece because the rest of it you can just learn by knowing a 360 is all the way around and a 180 is a half turn. We use this terminology a lot in real life. 360 is like in basketball when you turn all the way around and dunk. And a 180, when somebody does a 180, that means they completely turn around their life. All right, so let's talk about negative angles. So negative angles go the opposite direction. We still start here at 0 and you still have your initial side here, but it just goes backwards. So if I go this way, that's negative 90 degrees. So it's just the opposite direction is negative. And then if I go further, this would be negative 180.
So now we're dealing with negative.
And it just means you're turning it the other direction. So this is negative 270. And if I come full circle, that'd be negative 360. So this is clockwise, actually, if that's...
Oh.
So negative is clockwise and positive was counterclockwise. And it just has to do with the way that our graphs are set up. They want those positive angles to be in the first quadrant. So it has to do with the mathy part of that. I'm going to erase this now that I'm done with that. Okay, so just 0, negative 90, negative 180, negative 270, negative 360. That's the most important things. So if I'm going to draw a negative 50 degree angle, I'm still starting from here, but I'm going this way. So I turn my protractor upside down, and I want to use these numbers, 0, 10, 20, 30, 40, 50. So I'll make my mark.
Now we're using the top ones?
And now I'm using the other ones. I don't think of it as top and bottom because sometimes they do change from company to company, but I just try to make sure that, like, if it's 50, it's an acute angle. And then we label it, we're showing we're going from 0 to here, it's negative 50 degrees. So it's just going the other direction. So if we go back and look at what we had before, this was positive 50 degrees going this way. Negative 50 degrees goes that way. Okay, and so then if we're doing a negative 140, you're going to line this up, and we are using the other numbers. So you're going to go from 0, let me zoom out, you go from 0 all the way over to 140 over here, and I connect that back. And then this from here to here is negative 140. And then I had a little thing on here about more coterminal angles. And it's just got this nice picture that this angle going this way. Let's measure this one from here to here first. We'll measure the negative angle. It looks almost like this one, but I think it's supposed to be a little bit less. Let me extend this line out carefully this time. So that would be 135 is what I got. So negative 135. And to figure out what this other angle is, I could take negative 135 and add 360, or take 360 minus 135, and you find that this angle, if I go this way, is 225 degrees. But they're still coterminal because they have the same starting and stopping points. But they're very different because one's turning this way, 135, and one's turning this way, 225. But they still stop at the same place. Does that make sense? So then, if we go back up here to the negative ones, you can just subtract 360. So 23 minus 360, I'm actually going to have to do that because we're adding a little bit to my notes. So 23 minus 360 is negative 337. And then I can take negative 337 minus 360. and get negative 697, and take negative 697 minus 360, and we get negative 1057 degrees. So you can get coterminal angles by adding or subtracting 360.
So would the 383 degrees be coterminal with the negative 373 degrees?
This and this, yes, they would all be coterminal. They would all stop at the same place.